Welcome to the Beyond Tech podcast, a podcast designed for engineers. We look to bring clarity around safety and give you all the information that you need in order to make an informed decision when designing a safety system.
We cut through the noise and we have tried to avoid those typical statements like robust and reliable. And we look at the challenges of the real world when discussing these technologies rather than just what's stated on the data sheet, which tends to just look at best case scenarios.
Each episode, we take on one gas or flame detection technology and we break it down, how it works, when and where to use it, potential drawbacks, and any maintenance requirements. UGLD is the topic of this week's episode, and it's a little different from the other sensors that we've previously looked at. UGLD, in simple terms, is listening for the leak.
Well, that's very simple, very simply put, but luckily we have product manager Mirko Leonhardt joining us. Welcome, Mirko.
Welcome.
Hey.
Thanks for joining us.
Yes, so Mirko, you've been with Dräger nearly 26 years, but since 2019 you've been specialising in UGLD detection. So welcome. We have a small this or that format icebreaker if you're ready to take part, just to get to know you a little bit better.
So the first one is early bird or night owl?
In the past, night owl, early bird, now in spring and summer.
Lovely. Coffee or tea?
Espresso,
Oh, nice.
black without sugar.
No milk.
Always, very often.
Nice. Cats or dogs?
Cats,
Pizza or burger?
neither nor.
Okay.
As a healthy man. And then on a holiday, is it city break or country escape?
Country escape,
Very nice.
Italy preferred.
Nice. I've never been, but I would love to go. So let's get into the main section. So how does UGLD really work? Can you please tell us?
First, I would like to explain the abbreviation UGLD, that stands for ultrasonic gas leak detection.
Mm-hmm.
So, to understand, I like to explain a little bit
Mm-hmm.
about sound.
Yeah.
And normally we are listening to audible sound,
Mm-hmm.
and that we can specify with a frequency range,
Mm-hmm.
and that is between 20 hertz and 20 kilohertz.
Okay.
So
And that's the sound that we can hear with our
absolutely,
ears?
yes.
Yeah.
So, and for instance, 20 hertz, it's a subwoofer. It's
Mhm.
very, very low.
Yeah.
Mm.
And 7,000 hertz is a cricket.
Mm-hmm.
Not possible for me anymore to
Yeah.
hear, but yeah.
Yeah. So high pitch.
Yeah.
That's the top end
Yeah.
of the human
So-
ear.
You mustn't be able to hear up to 7,000 hertz, Graham.
No,
huh?
certainly not. No, those days are gone.
So, and that is a physical size we know and we can understand,
Yeah.
because we can hear it.
Mm-hmm.
So, and this is the sound, and then after this audible sound comes the ultrasound.
Mm-hmm.
Ultra
Okay.
means the only difference is the frequency range is much higher. So, and it starts at 20 kilohertz and goes up until 200 kilohertz.
Yeah. Okay. So why do pressurized leaks actually generate ultrasonic sound?
So now coming to sound, if we have, for instance, a pipe filled with gas,
Mm-hmm.
and if this pipe, the gas is pressurized, then we have a flow in the pipe.
Yeah.
So normally then if it's at a very low pressure, it's a laminar flow
Mhm.
in the pipe.
Mhm.
And in case there is a leak, a scratch in the pipe, it will leak, but it will not create ultrasound
Okay.
because flow is too slow.
Right.
Okay. So you need
So-
that higher flow rate in order to create the ultrasonic sound.
Yeah, exactly.
Okay.
So not all holes in a pipe could make ultrasound, or would they create ultrasound but at different levels? It's hard to say, I suppose. No one leak hole is the same, right? Yeah. Okay.
So, and if there is higher pressure in the pipe, then consequently there is much more flow. And then if there is a certain flow reached, so-called choke flow, then we will get turbulent flow.
Okay.
And that's what creates the noise when it's turbulent
And
flow rather than
when
linear?
this turbulent flow escapes through a small leak, then ultrasound is created.
Oh, okay. So the detector or sensor that's placed near the leak source, does it have to be very close to it, or can it be a little bit further away? Like, how far can it hear?
It depends on many parameters,
Oh.
but I would say roughly between 3 and 30 meter.
Okay. So it can be quite far away then?
Yeah. But it depends on conditions.
Yeah.
One condition is the leak rate, and the leak rate is dependent on the pressure in the pipe, on the size of the leak, and the kind of gas.
Yeah. So would a customer have to know all of these parameters before they chose an ultrasonic gas detector, or like would they find this out themselves, or is there ways and means of finding out this information?
Depends on customers. We have some customers like Linde. They are engineering their plant itself, and they know everything about leakage sizes and other applications. In clean tech, for instance, these customers are not so familiar with this conditions, and so we can consult.
Okay, so there's kind of a consultancy-based process in order to find out the right solution.
Also in the first step, to find the answer on the question, can we use ultrasonic gas leak detection for this application? Yes or no?
Yeah.
Compared to other gas detection technologies, can we measure this gas? Yes, no.
Okay, and then so the sound is created and the device is put in the right location. We understand that the ultrasound will be produced by the leak. Can you explain to me how the device actually works? Is it just very simply a microphone, or is there anything that we should consider?
It's really easy. It's for the audible sound, we can use our ears, and we have a membrane in the ear which will convert the pressure fluctuations, the sound. And if we go to, it's like a microphone, the ear. Microphone membrane, and if we go to our ultrasonic gas leak detection, then we have here this sensor, UGLD sensor, is the same form like our electrochemical sensors. Can be operated in belonging transmitters. And this sensor contains a microphone. It's a piezoceramic membrane here. Behind this plastic coverage. And then there are a lot of electronics inside. And this microphone will convert the sound signals into electrical signal, which then will be proceed in a transmitter.
Okay.
So what's the output then? What on a device? I mean, we've looked at other sensor or technology types, and it's very clear, right? It's the concentration either in parts per million or percentage LEL. What's the output on an ultrasonic? And is it kind of a leak or no leak kind of scenario, or is there a scale in which you could output?
So, this is a big difference to the conventional technologies. These technologies like infrared, catalytic bead, and so on, they will detect gas concentrations, and this sensor, a microphone, is not able to detect concentrations of gas. It will detect the sound created during a leak,
Right.
which brings all the advantages in the game for this technology.
And with it being a microphone, it must pick up also background noise. Is that something that a customer has to understand and be able to quantify, like how much background noise there is? Like, what does the background noise mean in terms of this sensor?
From my point of view, the most important point of this technology, the biggest advantage.
Okay.
And the advantage is it's very, very fast.
Okay,
Yeah.
the response time
Yes.
is fast.
Much faster than infrared catalytic electrochemical point detectors.
Sure.
And so that means we have a very short response time. And so for all applications where a very short response time is required, ultrasonic is recommended because this is essential part of safety systems.
Okay. So it gives you a much faster response to detect a leak. So I guess what we're saying is we can pick up a potential leak before a gas cloud forms.
Exactly.
Yeah.
So
Okay.
a point detector is detecting gas coming from a leak. And
This is detecting the leak.
Yeah.
And the UGLD technology is not waiting for the gas.
Yeah.
If the gas escapes from a pipe, immediately the sound is created and arriving the detector. And as I mentioned, 30 meter, and the velocity is 330 meter per second.
Yeah. Speed
And
of
so
sound.
it's speed of sound, it's really, really fast. So, and this is a biggest advantage of this technology.
I mean, would you replace the types of detection with this, or would it be more a complementary technology to improve that speed of response?
I would say it's a must for safety systems, and the best solution we recommend is to offer a complete detection portfolio. Means for fast response time, the UGLD, for quantification of gas concentration, the catalytic bead or infrared, depending on application, what gas is to detect, followed by flame for the visual detection.
Yeah. Amazing. Is there any sorts of leaks that the UGLD detector will miss?
So that is really, really easy to say. We speak about gas leak detection because only a gas can create turbulent flow and ultrasound. So, for instance, if you have a pipe filled with propane at 20 degree, 20 bar, and if you have a leak, nothing happens because propane will be a liquid then.
Okay.
And then there's no gas coming out the pipe.
Yeah.
And so no chance to detect because no ultrasound is created.
So it's if the pressure's too low, if it's a liquid phase, we assume any gas under pressure that will pick it up.
Yeah.
Yeah. Okay.
There is a only restricting parameter is you have to have ultrasound, and that is dependent on the leak rate, and that is dependent on the pressure. So the thumb of rule 2 bar. It's an absolute minimum.
Right.
Yeah.
But it would depend on the gas.
Absolutely, yeah.
So are there any specific standards around UGLD that everyone needs to be aware of?
Yes, there is the really new standard released 2 years ago, EN 5724. describing selection and installation of ultrasound gas leak detectors.
And where's that applicable? Is that everywhere or Europe?
It's a Senelec standard, applicable everywhere.
Global standard.
And then, based on this standard, some countries already developed own standards, especially for H2 detection, for instance, for H2 petrol stations.
Yeah.
And they have the real recommendation for the country to install UGLD for hydrogen stations.
Is hydrogen a particularly good gas for ultrasound production?
It's absolute the number one,
Yeah.
because it's really sensitive.
Okay.
So, in terms of sound detection, sensitive means it's very loud.
Oh, okay.
Okay.
So, compared to methane, for instance, it's, of course, depend on conditions.
Yeah.
Factor 10 to 100. So,
Oh, really?
means we can detect leaks of methane 10 gram per second. Also, we can detect leaks of hydrogen, maybe 0.1 gram
Wow.
per second.
That's a
Yeah, that's
huge
a big
factor
difference, yeah.
Yeah.
And I suppose with hydrogen, small molecules means very difficult to contain, and with is it 4 times lighter than air, something like that with hydrogen. Anyway, so a leak will rapidly
Shoot up.
and then it's very difficult to accumulate. So I suppose with it being a good producer of ultrasound, plus the fact that it can be difficult to accumulate, then this is where the ultrasonics really coming into play with the hydrogen.
It's easy to understand. Also, if you imagine the sound and the intensity of the sound depends on the kinetic energy. And if you imagine you have a hydrogen molecule, kinetic energy is velocity square.
Right.
And because hydrogen is so fast compared to methane in air, and then therefore it's so much more energy and will create much more noise.
In other sensor types that we've looked at, there's been external factors that could act as a drawback. So temperature, humidity, dust, for example. Is there anything with the UGLD that could also act as a drawback?
So I think obstacles in between of a possible source of leak and the detector will reduce the signal, of course.
Yeah.
Temperatures will have only a very, very little influence. So this is also compared to audible sound, where we can hear it. Maybe it's a little bit clearer when it's colder.
Yeah, crispy.
Yeah, and so it's similar for the ultrasonic
So,
range.
Because it can't pick up, it can't tell if it's a specific gas. So I guess there are other sources of ultrasonic leaks elsewhere. So I'm assuming on most sites, right, there will be some sort of background ultrasonic. How would we either survey the site or set up the device to get around those potential cross interferences?
So our first recommendation is to do a field survey with our educated people with all the stuff on site. And during the field survey, we will verify the best location for installation of the instrument and the best configuration, considering then also the background noise.
Okay.
So, and the background noise we will measure with a device in best condition over a longer time of period, so that we can capture a long time frame, different running applications at the site. And then we have an overview about the background noise possibly on site, and so we know for some applications, industrial environment, we have compressors, machineries, welds, creating audible noise and also ultrasonic sound, and that has to be considered during installation.
Okay.
Yeah, I mean, I've seen in the past where air brakes for a lorry, a supply lorry, has triggered the ultrasonic leak detection. Obviously, there's no getting around. You can't stop lorries going on sites, but from memory, the customer delayed the signal because they knew, for example, the air brakes may operate, but only for half a second, right? Yep. So what they did was delay. They want to see a leak that lasts for longer than 1 or 2 seconds, for example. So is that common to delay that signal?
This is common. It's also recommended in this Senelec standard.
Okay.
Of course, we know this is a contradiction of the biggest advantage, fast response time, because it will reduce this factor
it's no
a little
longer
bit.
so fast.
And so, we have to find the best
like a balance
for highest safety for the customer.
Okay.
But of course, there's been scenarios where assets have leaked gas for many days, and because the wind's going in the wrong direction, right, it could be.
It's not picked up.
Yes, exactly. So
I think
small delay is maybe not a big concern. Maybe.
So that is the first point for UGLD. Biggest advantage, fast reaction time, and the second one, huge advantage is it's independent from wind. So if you have point detectors, then the gas molecule has to travel to the detector, and that depends from different factors, among others wind.
Yeah.
So, and if the wind is coming from the wrong direction, then detection is not possible, which is dangerous. And for this case, UGLD is a perfect complement.
Yeah.
Because it will detect the sound waves from such a leak always, independent on wind direction.
Yeah.
So a strong case to use it on outdoor applications where you've got the
absolutely
open spaces.
It's also a recommendation to use it not in small indoor application, because then we will have reflection on the walls, and then the measuring signals are a little bit
like amplified.
irritating.
So when we look at the installation, is there anything particular that we need to consider for the ongoing maintenance? So we've looked at in the past other sensors, orientation, does that affect the sensor? And also access, so for later on down the line we need to look at maintenance. So and I'm assuming an elevated location is an advantage just because of the detection range, is that right?
Absolutely. As we could detect the leakages if the sensor here, for instance, is installed 20 meter in height, and then everything in the hemisphere here will be detected as specified. Of course, here also in the other hemisphere it will be detected, but without specification.
Okay. So we're looking at that cone.
It's a hemisphere.
Hemisphere, okay.
So, and it depends also on the kind of microphone and on the dimension of the microphone. So,
is there different types of microphones?
Yes, and for our microphone, it's a hemisphere.
Right.
Okay.
So an elevated install would be an advantage above the leak site.
So, and also we have a remote option, though that means we could install the sensor 20 meter in height and the belonging transmitter in normal position, easy to access.
Okay, yeah, that makes sense. Is there anything that people would need to bear in mind or think about in terms of calibrating the device? Is there a set standard that's laid out in terms of time periods that it needs to be calibrated?
From our experience, calibration is not necessary.
Okay.
We recommend a calibration interval of 10 years.
10 years, wow.
And of course, we can calibrate the sensor. We offer also a calibration kit. And so with the calibration kit, we can check the calibration.
Yeah.
So, and if it's a customer...
And check it's performing as expected.
Yes. That is one thing we can offer. Also, we offer a simulation of real leaks to verify correct installation and configuration of the transmitter. So in configuration, I mean alarm thresholds, and it means the delay time.
Yeah.
And this we are performing by our commissioning kit, where we can simulate real leaks of hydrogen by air.
Okay.
So it's not dangerous for the customer.
Yeah.
Just using compressed air and then different hole sizes, or how's that done? Do we use particular gases, or is it just compressed air?
We can use any available undangerous gas, nitrogen. So need, of course, the correct pressure reducers. And then we have our range calc tool. And with this range calc tool, we can calculate exact the pressure of air we have to apply to simulate a leak of 50 gram per second methane, for instance. So which makes work much easier for the people who are commissioning the installation.
Okay. Well, thank you, Mirko. That was very interesting. But before we go, we like to ask you 3 questions, just as act as key takeaways for the viewers. So, the first question is, when would we choose ultrasonic leak detection? And so, when would we choose it, and when it's the correct choice of device?
If we have safety systems, response time is an essential factor. Means if we have to detect very fast, we need ultrasonic gas leak detection.
Perfect.
And by the way, we have also the SIL2 certificate by TÜV Süd to be able to install our transmitter in safety integrated systems.
Oh.
Okay.
And then the second question is the biggest limitation that people often forget or overlook?
It depends on application. There are applications which we cannot cover by UGLD because background noise influence is too big. For instance, LNG filling station for lorries. So.
Okay.
Yeah.
So it's not suitable for every single application. It's very much application.
And therefore, the field survey is recommended, and of course, before speaking with the customer.
Okay. Yeah. And the last one is, what's the key thing to remember for the maintenance?
10-year no calibration.
10-year no calibration.
It's easy.
Nothing, because also we have here 2 concentric rings inside, and every few seconds these rings will be moved, creating ultrasound.
So it self-tests?
Exactly.
Okay.
And it's always ensured that the microphone is working.
Yeah.
Excellent.
And if this self-test is failing, then a failure message will be given out, and then that would be a case for maintenance.
Yeah.
Exchange the sensor, which is easy because it's
plug and play,
intrinsically safe, no declassifying necessary.
So if I may take another key takeaway is that ultrasonic leak detection, it needs some thought and consideration before the installation.
Yeah.
But once it's installed and the background levels are understood, the maintenance is far different from other devices, right? It seems
I think if you understand the site and the needs of the site, then and you want those fast response times, then it's a perfect detector, isn't it? As long as you understand the site.
Yes, which is not so easy for greenfield applications, for instance.
True. Which many of the hydrogen projects are these days. Mirko, that's really insightful. Thank you so much for your time.
Yes, thank you, Mirko.
Thank
Well,
you.
that's a wrap for this episode of Beyond Tech podcast. If you are working on a project and you require more in-depth information about the technology types, then please head to our website, dräger.com/EPC.
And we hope you found the information useful and beneficial, but be sure to let us know if there's anything that you would like to see in the future.
So on to the next episode, which we go and look at another technology, but the rules are the same. No products, no fluff, and we look at the real world applications.
Yeah, thank you.
Thank you.